All right, let's dive right into a pretty wild what-if scenario. This is a thought experiment that's, both terrifying and kind of beautiful in a strange way. We're going to explore what would happen on the day our moon died. So, what would really go down if our celestial neighbor, for whatever reason, just started drifting closer to us? What happens when it gets, well, too close for comfort? Now, I bet your first thought is a massive, world-ending collision, right? A giant impact. But the reality, according to the laws of physics, is so much weirder and honestly way more dramatic. The moon wouldn't actually hit us. It would be completely destroyed before it ever got the chance. Okay, so let's set the scene here. Imagine you're looking up at the night sky, but something's just wrong. The moon, our old familiar friend, is getting bigger. Night after night, it just looms larger and larger, drifting dangerously close. This isn't just a cool view. It's the start of a scenario that would change absolutely everything for us here on Earth. See, this whole thing isn't about a collision course. It's all about crossing a very specific, invisible line in space, a true point of no return. Think of it like a gravitational tripwire that, once crossed, seals the moon's fate for good. Now, to really get what happens next, we have to talk about the incredible forces at play. This is a story all about gravity, but not the gentle pull that keeps our feet on the ground. No, this is about gravity as a relentless, world-shattering force. That invisible boundary has a name. It's called the Roche limit. And it's basically the point where a planet's gravity becomes so powerful, so overwhelming, that it can literally tear another celestial body to shreds. For Earth, that limit is about 18,000 kilometers away, which, believe it or not, is closer than where some of our own communication satellites orbit. This quote on the slide just nails it. It really is a gravitational tug-of-war. On one side, you have the moon's own gravity, desperately trying to hold itself together. And on the other, you've got Earth's immense gravity pulling it apart. And as soon as the moon crosses that Roche limit, Earth's pull just becomes way, way too strong. It's a fight the moon was always going to lose. And this isn't some quick explosion. It's a gradual, kind of brutal process. Just like you see in these steps, Earth's gravity yanks on the side of the moon facing us much harder than it does on the far side. This difference in pull creates this unbelievable strain, literally stretching and warping the moon like a piece of cosmic taffy until it just can't hold on anymore. And now we've arrived at the event itself, the Great Shattering. These are the final, absolutely spectacular moments of the moon as we know it. I mean, can you even imagine watching this unfold? In that final hour, you'd see these enormous cracks spider-webbing across the lunar surface. Then, with only 10 minutes to go, whole mountains and giant chunks of rock would start to shear off. In the last minute, the moon would be stretched into this grotesque, unrecognizable shape, and then, in an instant, it's over. And just like that, the moon is gone. It hasn't vanished, but it's been completely transformed. In its place is this rapidly spreading cloud of rock, dust, and ice. Literally trillions of pieces of what used to be our moon, now all trapped in orbit around the Earth. But the story doesn't end there. Oh no. For us down on Earth, the aftermath would be the beginning of a totally new reality, a completely new sky. Just look at this difference. The night sky that we all know and love would be gone forever. In its place, you'd have this breathtaking system of rings, just like Saturn's, stretching from one horizon all the way to the other. A permanent, brilliant new feature in our sky. This new world would be this crazy paradox of incredible beauty and incredible danger. Our nights would be almost as bright as day, constantly lit by sunlight reflecting off the rings. But we'd also be living under a constant rain of debris. Sure, dazzling meteor showers, but also a relentless threat to every single satellite we've ever put into orbit. You know, this whole thought experiment, it's not just some fun sci-fi story. It's a really powerful reminder of the incredible forces that are constantly shaping our existence. The reason our moon is a beautiful, stable sphere and not just a ring of debris is because it exists in this perfect gravitational balance. It's a delicate dance, and this scenario just goes to show how fragile that balance truly is. And that leaves us with one final, pretty profound thought. We would be living under this stunning celestial spectacle, a monument to raw cosmic power. But we'd also know that this beauty was born from total destruction. How would it change us to look up every single night at a beautiful glittering graveyard in the sky? It's really something to think about.